This is section 3.6, Prove Theorems about Perpendicular Lines. So we have a few theorems to go through in this section. If two lines intersect to form a linear pair, so like this, okay, so if two lines intersect, let's call those H and G, to form a linear pair. So remember, linear pair means they make a line. And those angles are congruent. Okay. Then those lines have to be perpendicular. So that kind of makes sense because a linear pair, remember, is 180 degrees, and if the two angles are congruent, they both are 90. And perpendicular means they make a right angle, which is 90 degrees. So in words, if then angle 1 is congruent to angle 2, then G must be perpendicular to H. Okay, because they make a linear pair and they both have to be 90, which means they're right angles. So the next one, if two lines are perpendicular, let's call those A and B, then they form four right angles. So they're perpendicular and they normally only draw one of the angles, but because they're linear pairs, then this one has to be 90, and then this one has to be 90, and this one has to be 90. So each of those four angles would be a right angle. So they normally are only going to draw one, but all four of those are going to be right angles. Alright, so what can we conclude by angle 1 and angle 2? So up here it says line AB. This symbol means perpendicular. So if you see that, that's what that means. To line BC. So AB is perpendicular to BC. Perpendicular means that they make right angles. So we could conclude that angle 1 is congruent to angle 2 because they're both the right angles. Next thing, if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So drawing that, say we have two adjacent angles like this, and that's a right angle, and this is angle 1, and this is angle 2. Let's call this big angle A, B, C. So if the rays BA is perpendicular to the ray BC, okay, then that means that that whole angle is a right angle, which means that angle 1 and angle 2 are complementary. Okay, because if they're perpendicular, that makes a right angle. If the whole thing's a right angle, that means angle 1 plus angle 2 adds up to 90. And angle 1 and angle 2 adding up to 90 means they're complementary. So we could prove that and write that out just for practice. Okay, so in this picture it's ED is perpendicular to EF. That's given to us. If they're perpendicular, we know that angle DEF is 90 degrees. So measure of angle DEF is 90 degrees. Okay, because that's perpendicular. So that's definition of perpendicular. So if we look, DEF in the picture, yep, is indeed 90 degrees. We also know that the measure of angle 7 plus the measure of angle 8 equals that whole angle, DEF. Add this angle and this angle to get the whole thing. Okay, that's our angle addition postulate that says we can do that. Okay, and now we notice this part here is DEF and so is this, so I can substitute the 90 in. So measure of angle 7 plus the measure of angle 8 equals 90 degrees. Substitution. Okay. And if they're 90 degrees, that means they are complementary, which is what we wanted to prove. So angle 7 and angle 8 are complementary. Okay, and that would be definition of complementary, because we know complementary means 90 degrees. Okay, so we could just use that now. If they're right angles, then they're going to be complementary. So last few theorems. Perpendicular transversal theorem. If a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other. So let me draw a picture to kind of explain that. So these two lines are going to be parallel. Let's call those H and K. Parallel means I need to draw my little arrows. Okay, so H and K are parallel. So if a transversal is perpendicular to one of them, so let's draw a transversal, T. So if it's perpendicular to one of them, and since the lines are parallel, then it has to be perpendicular to the other. So in words, if H is parallel to K, and T is perpendicular to H, then T must also be perpendicular to K. Okay, and we could do that with like our corresponding angles. If these two lines are parallel and this is a right angle, then this one has to be a right angle as well. Okay, so then they would be perpendicular. The next one, lines perpendicular to a transversal theorem. In a plane, if two lines are perpendicular to the same line, then they must be parallel to each other. So basically the opposite of what we just did. Here's my line P, and I have lines M and N. So M is perpendicular to P and N is perpendicular to P. So M and N must be parallel to each other. Okay, so that would be like our corresponding angles converse. These are both right angles, which means then they're corresponding, so M and N are parallel. So in words, if M is perpendicular to P and N is perpendicular to P, then M is parallel to N. Okay? Alright, so last thing, determine which lines, if any, must be parallel. Okay, so if they are perpendicular to the same line, okay, then they would be parallel. So let's look. First of all, P and Q are both perpendicular to line S. So P is parallel to Q. Okay, both perpendicular to S. Okay. What other ones would we say? Well, S is perpendicular to Q. T is also perpendicular to Q. So S would be parallel to T because they're both perpendicular to Q. So we end up with P being parallel to Q and S being parallel to T. So these two lines are parallel, and these two. Okay, that's it. Oh, wait, we have one more thing. Distance from a point to a line. Okay, so if I have a line and some point, now there's many ways I could draw a line down to this line. So from this point to the line, there's infinitely many ways that I could draw a line. So there has to be one specific one that we're going to draw if we're trying to find the distance between those two. And we want the shortest distance. So to get the shortest distance between a point and a line, it has to be perpendicular. So it has to form a right angle. Okay, so you'd want to go straight down so that it was a right angle. Okay, that would be the distance, that line, because that's the shortest, and so we're going to use that one. So find the distance, graph the line y equals x plus 1. What point on the line is the shortest distance from the point 4, 1? What is the distance? Okay, so let's go ahead and graph that first. So I got my x and y axis graphed. Remember, to graph this line, we'd start up at 1, because that's my y-intercept. And then my slope is 1 over 1, since it's 1x. So you go up 1 over 1. Okay, and you can draw your line. Okay, so that's my line. And now 4, 1 is the point we're looking at. Okay, and we want to know which one is the shortest distance. So remember, the shortest distance is the perpendicular distance. So since my slope of my line is 1 over 1, the slope I'm going to use to find the shortest distance would be the reciprocal. So flipping it, you can still get 1 over 1. But it has to be opposite reciprocal, so it'll be negative 1 over 1. Okay, so we can do that. Instead of going up and right, we can go up and left. That would be negative 1 over 1. Okay, and we just have to figure out which point I hit on my line. Okay, so the shortest distance would be this distance here. That's a right angle, because the slopes are opposite reciprocals. And they actually want to know what that distance is. So remember, to find the distance between 2 points, so 4, 1's our 1 point, and our other point looks like it's 2, 3. Remember, to find distance, we use our distance formula, which are subtracting x's squared, and then subtracting the y's, and also squaring those, and doing the sum. So let's go ahead and do that. The x values are 4 and 2. The y values are 1 and 3. So don't forget the square root all the way down. 4 minus 2 is 2. 1 minus 3 is negative 2. So we got 2 squared and negative 2 squared. Those are both 4. Then 4 plus 4 is 8. So it's the square root of 8. And you could approximate that if you wanted to on your calculator to approximately 2.8. So if it asks to find the distance, make sure you're doing the perpendicular distance. So that is it for this section.